So our study is about discussing the challenges and applications of using virtual reality in education. Through reviewing the current state of virtual reality in education, we highlight the critical aspects of user experience within these VR educational applications. So let's start by looking at the outline of our presentation. I'm going to start with a brief introduction and then discuss the results and in the future slides. So VR creates incredible prospects to enhance students' performance and learning. It offers engaging and immersive learning environments and allows students to interact with subjects in novel ways through maybe virtual laboratories or 3D models and simulations to improve the understanding and comprehension of these complex topics. And user experience design refers to the process of creating useful and desirable products based on the user's needs and preferences and previous background in using virtual reality applications. So it plays a crucial role in the successful implementation of a virtual reality product in educational contexts. Therefore, the goal of the study is to first review the advantages and challenges of using VR in education by reviewing the existing applications of educational virtual reality systems, and then identify the influence of educational VR systems on user experience. The methodology of our study is defined. The search string was virtual reality and user experience in Web of Science database. We only included review articles in English. And after that, we had 51 studies. And from those studies, we only included educational or training related articles. And the results can be grouped into two. So the first one is K-12 education. Mainly it was primary and secondary education. And the second one is higher education. In higher education, we only found applications related to healthcare. So this was either dentistry or surgical training. I'll start by the first one. So in primary and secondary education, virtual reality was used for STEM education, which stands for science, technology, engineering, and mathematics. In STEM education applications, students reported improved learning outcomes, and the effectiveness of teaching was also increased based on the instructors' feedbacks. And the usability was also increased compared to traditional methods inside a classroom setting. Using VR applications and in primary and secondary education, using game-based learning was better suitable for topics that require hands-on learning. So learning by doing tasks, and in-game problem-solving exercises were also found to improve the students' solutions to problems compared to traditional classroom setting. And the most successful VR-supported instruction strategy was the discovery approach, where students are encouraged to build their own knowledge through more self-directed learning experience. And engagement is a key term here. It refers to the students' collaborations between other students and with their instructors. Virtual reality systems were reported to increase engagement within primary and secondary education, especially during collaborative tasks in group settings. It leads to increased problem solving and better self-discovery. And also related to cognitive thinking skills, most research on primary and secondary education report that students improved cognitive thinking skills, especially related to creativity and problem solving and critical thinking, and more of a deep understanding on complex topics. Because VR creates an environment where students can work in groups more efficiently, they can study in their own time, and they can engage in a more self-controlled learning environment compared to an environment that's led by instructors. And also in instructional design in primary and secondary education, virtual reality helps students use their prior knowledge and their experience within a VR setting transfer to real life, which improved their conceptual understanding. And through the use of virtual reality educational applications, students can direct the learning materials more hands-on tasks and receive immediate feedback while they're doing a task or right after finishing a task from their instructors. So students can be more focused on the experimental assignments that encourage the practice of learning by doing, while they can also identify their own mistakes more accurately compared to a traditional classroom setting. And also VR was found to help students better visualize their ideas because they can see the outcomes of their actions in real time, and they can reflect on their self-learning experiences. And in the second part, in higher education, virtual reality offers a more safe and controlled environment compared to traditional methods where they have to interact with patients and learn by practicing on patients. In virtual reality systems, healthcare students or maybe practitioners can learn from their mistakes in a more secure and comfortable environment using simulations without putting patients' safety at risk. And also in healthcare, serious games were used. So serious games are any games designed for other purposes than entertainment. VR can be used to implement serious games. In healthcare education, serious games were used to achieve professional training, to train on technical and also non-technical skills, so interacting with patients as well. And the research shows mostly positive attitudes from healthcare students towards training with virtual reality and serious games in the field of healthcare. And there were three most popular virtual reality technologies in healthcare education. The most popular one was haptics. Haptics were mostly used in surgical education. The second most popular was computer simulations, and computer simulations were mostly used in nursing education or to train healthcare professionals, not students. And very few studies use head-mounted displays. And head-mounted displays were used to train the faculty inside the healthcare industry. All of these technologies can be used to allow students to perfect their skills while they interact with virtual 3D objects. And head-mounted displays may be used less frequently because they're a relatively new technology to the healthcare industry, or maybe they provide a higher level of immersion. So because healthcare practitioners need to be in contact with the patient, but head-mounted displays cut off all contact with the real world, it creates a virtual world. So head-mounted displays were not preferred in healthcare education. Virtual reality was in healthcare mostly used for surgical training. In traditional methods of training, more experienced doctors teach students or less experienced doctors during real surgery. But any mistake during a real surgery may be non-reversible. So virtual reality is more preferred in the recent years for surgical training, and especially in neurosurgical operations. In education for neurosurgery, extended reality has been used because it has the potential to offer a trial and error based learning method without endangering patients. So it's starting to be used more and more. So as many benefits virtual reality provides, there are still some challenges of using virtual reality in education. First of all, the technical equipment is not always accessible to a full classroom. Using the virtual reality headsets might not be as feasible to use in a whole classroom because it's still an expensive technology. And also students have problems using these equipments because they're not that familiar with it. And even if they are familiar with it, sometimes they get simulator sickness, which is a type of motion sickness where users might get dizziness or nausea from using head-mounted displays because of the high levels of immersion. And we have motivation. So especially in primary and secondary education, motivation was a key factor because some students, if they don't have the option to not use VR headsets in their education, they don't want to use it. So the motivation is a crucial factor here. If they don't feel motivated enough to use it, the technology cannot really help them to achieve better learning outcomes. Also, instructors reported feeling overwhelmed because of the number of students that they have to give feedback to. So there are a lot of students doing the same tasks in virtual reality, and instructors have to give feedback to them, maybe all at once, maybe during a classroom. And this process may be automated in the future using machine learning, but currently the instructors' feedback is still a challenge in VR in education. And the expensive cost of some computing devices in virtual reality, and also the novelty effects of their unfamiliarness with these devices are also a challenge in employing these devices in education. There are some low-cost VR headsets, such as Google Cardboard, which offers a more affordable and portable alternative to high-end devices. But even as cheap as they are, they still offer some challenges too. Some students report higher levels of simulator sickness when they use low-end devices like Google Cardboard. So it's a trade-off between cost and simulator sickness. And most research shows that creating these VR applications to use in class takes a significant amount of time, especially starting from the development parts, and because the instructors have to also be involved in the development, it takes a lot of time from the instructors as well. In a traditional classroom setting, instructors don't have to spend that much time to develop teaching materials, but in virtual reality applications, they have to spend a lot more time. Again, the development of course materials. Also, this is a challenge for the instructors. They have to be involved from the start with the programmers and developers of the virtual reality applications. Some concerns here related to realism and the usability of the VR applications may be resolved in the future as the technology grows further. And finally, we have the implications on user experience. User experience has a significant effect on the learning and the motivation of the students, according to earlier studies. Each experience is distinct and individual because students bring their own experiences inside the VR application, and we don't know the background of each student. So it's hard to provide a standard, but there are some factors of user experience that are found to be more influential on the experience. First of all, we have realism, the perception that the perception of realism that the users encounter while engaging with the virtual environment refers to how realistic the visuals are, and also how natural the interactions with the system are. So if the system is not realistic, students feel disconnect between the system and their education, and it can easily distract them. And so the quality of teaching and learning outcomes increases with the simulation's realism. And next we have immersion. It's a key factor in virtual reality. It refers to the extent that the users feel submerged within the environment. And as the immersion levels increase, the students feel more engaged within the environment. So the learning outcomes are also affected by immersion. Also, presence has a profound effect on teaching outcomes. Presence refers to the feeling that the user gets while using the virtual reality headset or within the VR environment. And it's the feeling that they get when they feel physically present inside the VR environments, like as if they are actually there. So the feeling of presence also is linked closely to their attention span within the virtual environment. And as the levels of presence that they feel increase, they are more immersed within the environment, and they can pay more attention to the teaching material. Engagements refers to how refers to their engagements within the system between their instructors and their the other students. It's also important in education. It's especially important in classroom settings too, but it's important to provide a level of engagement within a VR application to keep that sense of the classroom setting. And in virtual reality, flow refers to a psychological state where the user feels completely immersed and absorbed within an activity. So the flow occurs when the student feels a challenge presented by a virtual system. And that challenge has to be hard enough to keep their attention, but not too easy, because if it's too easy, then they get bored. So it's important to keep that challenge at a challenging level, but not too challenging, to achieve a state of flow. And it's also important to note that all of these aspects of user experience are interconnected somehow, where improvement of one of them affects the other. So the immersion is directly linked to realism as well as presence and engagement. So instead of just focusing on one of them, it's important to consider them as a whole instead of only expanding on one. And many of these factors were proven to be induced by virtual reality technologies, but there aren't many studies that measure the learning performance compared to these user experience factors. Only studies relating how the user experience is affected by these virtual reality applications. So in conclusion, we talked about how VR technologies have applications in educational contexts, including K-12 and higher education, which is primary and secondary or higher education. And students have mostly positive impressions while using virtual reality applications, even though they might feel some challenges while using the technology. Those challenges need to be resolved in the future. And the most valuable or the most mentioned factors of user experience in educational VR applications were found to be realism, immersion, presence, engagement, and flow. And there are also some limitations of VR technologies in education, which include limitations in usability, realism, and most importantly, the lack of availability of VR tools due to high costs. Thank you for listening. If you have any questions, I can take them. I have my references here.
Thank you very much, Gulsah Hocam. You have made a brilliant presentation. We could have an overall picture of the affordances and challenges of VR on education and on the implications for user experience. I think there are two questions from the chat box here by Shamil Humbatov. Thank you. The first question is, which of the universities providing medical education in the world use immersive technologies in the teaching process?
So these were only test trials. I haven't found any universities that regularly use immersive technologies in the teaching process. These are only controlled trials about teaching medical education.
Okay, thank you. And the second question is, after virtual surgery experience, do doctors who perform real surgery on patients have fewer or more complications?
Again, unfortunately, these studies were pretty new, so only the educational effects of the virtual surgery were recorded and reported. The long-term effects, such as the doctor's complications after learning virtual surgery experience, were not reported. So,
okay, thank you.